Welcome to this is our third series now, third in series of using Wherobots with our new AI assisted tools to build and do some different analysis. Today, we are focusing in on our emergency preparedness use case. So I'm excited to have everyone here. If we haven't met before, my name is Matt Forrest. And I head up all of our customer education, as well as our workflows for bringing people on and helping them use the product here. So that's my job here at Wherobots. We have been doing this series talking about some of our new tools, specifically with our MCP server, and integrating in with a variety of different tools, building AI development workflows and stuff like that. So those are some of the things that we're doing. And we've actually built those out, and we're focusing in on emergency management today. So a few things before we get started. There's a chat here. You should all be able to access the chat as of now. I think I set that on. So if you want to let me know where you're joining in from, I'd love to hear where you are joining us from today. And a little bit about what you do if you are focused in this area, if you're just generally interested in spatial data, some of those different things. If you can drop that in the chat, that'd be great so I can get a sense of who's here today. And then if you have a Q&A, if you have a question, you can also drop that in the Q&A so I can get those logs. Sometimes I have to go back through the chat to do that as well. So occasionally I have to do those different pieces there, and that adds a few extra steps to do some pieces there. So that helps from that perspective. So let me just go ahead and get started just to kind of walk through a little bit about our platform and some of the pieces that we do. And I can kind of show you how some of these things connect and stuff from there. So I see Tucson. Yeah, let me know where else people are joining in from. Yosemite. And yeah, let me know. Chattanooga. Yeah, let me know if you're kind of focused in on some of these different topics, if you're generally interested in some of the AI tooling and stuff like that, and some of the things that kind of brought you here, and we can talk about those different pieces. So let's go ahead and get started. I'll start with kind of a first introduction in terms of what Wherobots is and kind of help frame that. We'll jump into kind of giving you an example and demo of some of the data that's available to show you what you can do with Wherobots, and then we'll actually take a spin through some of the different kind of tools and components that are here. So I'm going to kind of show you two views of what we're doing. Some of this I'm doing live as we go, and then some of it has been kind of pre-built, because that's always the rule of demos, is something is inevitably going to fail. And you want to have some stuff ready to go and show. So there. So let me just give you a sense of what we are doing and help you kind of understand where we are today. So if you're not familiar with Wherobots, and again, you can drop a question anytime in the Q&A. Wherobots is basically, we're providing a context engine for the physical world, right? That's our goal here, is to actually build that out and allow you to do that. How we do that is based where our platform is based on Apache Sedona, which is a distributed query framework for spatial data. It allows you to build spatial analytics on large scale volumes and split that up and partition it. It's really only focused on spatial data. That's what we do the best. When I say spatial data, that could be anything from points, lines, and polygons and vector data to things like raster data and different workflows like that. That includes things like elevation or weather or anything that can be measured from satellites. And increasingly, we're adding capabilities for weather and climate-based data sets that allows you to look at that from time slices and things like that. So if you're familiar with those types of data sets, we provide access to those too. Now, the key here is that what makes it really powerful for AI-based workflows is that most systems, if you ask something from AI, you can give it a prompt. It may know something about a location, like, what's in Paris, France, or, what are the different pieces there. But if you ask it a precise question about Paris, it will probably have to refer to a different tool, because it may be time bound. You need to know specifically what time, or what area you're looking in. If you're asking about demographics, it may have some very general examples and stuff like that. But even more importantly, you want to give it very specific constrained views on, you want maybe the population within 300 meters of the Eiffel Tower, or maybe 3 kilometers would be a better measure there. And AI isn't going to do that because it needs a system on the back end to do that. Now you can connect in multiple different tools, and oftentimes APIs can do that. But if you need to do batch spatial analysis over a large area or even a small area and you need global data set access, that's something where Wherobots can be a very powerful partner to you to provide that. Now, a lot of the stuff that we can do is actually providing different, spatial use cases for large scale spatial joins. You can do things like GPS map matching. You can do, imagery detection and stuff like that. But what makes it really powerful is actually leveraging and connecting it with our AI tools. So we've just launched some different pieces, which is the series that we've been doing here to show you how to do that. And you can actually connect to our MCP server, which allows you to query both your data that you bring to the platform, as well as our open data, which we've been investing a lot of time in and bringing new data sets forward to. So you can ask questions like, compute the flood risk from sea level rise for all homes along the California coastline. Again, this is not something that AI could answer. It could have general information based on text. These are text-based modules. So, they can do certain text-based queries and stuff like that, but they don't have access to the spatial information and backend to actually make that available. So that's probably one key thing that if you've ever tried this before, it certainly can't, sort of be able to do that and do those different things. So now we can actually do all these different pieces and ask these questions. That's what we'll be demoing today, is actually showing you how to do that. Now, you can sign up and start doing this today. We have a trial that allows you 30 days free access and lots of credits to actually test this out. And we have a lot of open data that you can start with. That's the data we'll use today as the framing for the problem that we'll actually be building out around emergency management. So this is our team portal. As you can see here, there's tons of data that you can start with in the open data portal. This is different data from the 30-meter global elevation. We have the complete Overture Maps data set. We just added in storm warnings for the US. So this is collecting storm warnings every hour, which I don't even know that there's a place that does that. And then we have some different samples from partners that we're adding in as well. And then if you sign up for the trial, you get access to all this data too, which is the complete OSM catalog. There's a bunch of data from the US Census. I'm bringing in the complete 2024 ACS survey. So I'm adding a ton of data into this progressively, and you'll see some previews of that in this workflow that I'll bring forward. There's the complete, open buildings data set. There's just a ton that you can do. And the key here, again, is that underlying engine that we built is really efficient to saying, yes, the data is global, it's everywhere. But if we only want to take a specific slice of that data in one area that you're focused in on, it can do that really efficiently. And it has access to our full documentation to actually run those spatial queries. And it's running it basically bringing that in with spatial SQL. Right, we are the most function-rich spatial SQL tool, right behind PostGIS in terms of number of functions that you can do, and we're continually building in new ways to access this, both in terms of accessing the documentation, reading the data, but also bringing forward lots of information to query your data and stuff like that. So there's lots of stuff that you can bring in, and again, we're doing this through many different ways to connect this in. The one that, if you are looking at getting started, you can do this through AI-assisted notebooks, and it can actually build you a complete job using something like Claude Code or Codex or these different pieces here. Our CLI allows you to submit a job if you need to do that on your own. But what most people are starting to access and do this with is actually with Claude Desktop, and that's what we'll be doing here today, just to show you what we're doing here and give you a sense of what we're doing. So I'm basically asking some very simple questions around some emergency management use cases, right? Show me the largest wildfires by acre burned in Los Angeles since 2018. And I told it to use Wherobots. Now what it's doing, as I open this up, it's now connected into our MCP, and we just launched our direct MCP connection into Claude Desktop. So you don't even need to do this through VS Code. You can actually set this up, and you're connected directly into Wherobots via your MCP. And what it will do is it will actually look in and see what tools are available. Here's the things that I can do. I can build a spatial query. I can list the tables. I can describe the tables. I can execute a query and do these different things. It will actually look through the catalog and understand what's available. So here's all this stuff that's on my account here. that I have access to. You can actually go here and list the databases. So it's going to go through and using the text context that I gave it, which is basically nothing. I just told it to give me, LA counties that were burned. What can I do here? And you do that. So it's looking, it says, I see land fire. There's the US historic NOAA storms. It's going to keep searching and needs to clarify what this represents. So it's going to go through and open this up and see what's available. So it's just looking at my data. And I could have given it a stricter prompt, but just to tell you, if you're coming to this with nothing and you don't know the data that's in there, it can handle this for you and actually go through all these different pieces. So you can see the steps that it went through here, and actually shows me that this data set only covered to 2015, but it gave me all the biggest fires anyway. So these are the different fires through 2015 that were available in that data set. You can see how much was burned in these different fires in the area and all the different pieces. And I can actually tell me, okay, let me give me another question. How many buildings in the Overture data set are in LA County? So it can do this here. I gave it the step of continue because sometimes the MCP tools time out for some reason. And you can see here that it's showing that, there's 3 million or so buildings in LA County, right? And you can actually give that and it knows where LA County is. And it's actually doing this whole thing under the hood. So it's writing SQL here, checking that it has a valid connection, writing the SQL here to actually do that, and then executing this query here. And it built that all in the back end so I can actually build these things out. So that's what it's doing here. Then I asked it to give me the storm counts for LA County from the NOAA data set. And it gives me that, estimated if there's hail events with a size over 1 inch, lightning strikes, mesocyclone detections, local storm reports, stuff like that. So this is all the stuff in that NOAA data set. Now, this is what this data looks like normally. Historic, let me see, storms. So you can actually get access to this. I think here's the bulk data download if you really want to see it. This is it on HTTP. This is the data that I pulled in. So it has this full data set, goes back to 1950. It's super rich. It's available on AWS as well, but it's probably something you don't want to have to do the work of bringing in and keeping it up to date. We're doing that for you, and now that data is completely accessible and open for you to use with Wherobots. So you get this full storms database going back to 1950, and you can track all this information. It's on AWS as well. So I mean, the data is completely open. It's called the Severe Weather Data Inventory. So you can see it here. But now you can just query it. You don't even have to upload it or do anything. You can just start to access. And you can see here, here's the big four from LA County. And what I love about doing this in Claude, especially for exploratory data analysis, is before you'd have to write the code, build the notebook, do all this different work, I can just start to ask questions of my data now and get really detailed data back. So you can see here, this is the tornado vortex signatures. There's not a lot of hail, but there were some instances of that. You can actually do mesocyclone detections. That was the biggest one in local storm reports. And you can see it broken out during time. For some reason, 2015 was the biggest lightning year. And you can see what that looks like. It builds these really simple charts and you can explore that. Here's the local storm reports. So in this data set, there's actually local people reporting on storms in this area. So you can actually check what that looks like. And you can do a bunch of these different pieces here, which is great. You can check out flood, snow, hail, all these different things. And then what I asked it to do was actually give me, show me the historical severe weather warnings that covered any of that. So it can actually, this is the severe weather warnings table that's there right now. We just launched the newest up-to-date one. So that should be available and updating on a regular basis. And you can see here, here's the warning types that occurred inside LA County. So there are 83 flash flood warnings, 37 severe thunderstorms, and special marine, which are ocean warnings and stuff like that. So here's the area of those total polygons. Here's the area that fell inside LA County and different stuff like that. Are there any active warnings right now? And it said, no, there aren't. So the last one was on April 29th, based on when the ingest was. So it's actually checking that, and that data is up to date right now. And then it's actually doing some different pieces here to find that for each of the 10 largest wildfires, count the residential buildings within 3 miles of the perimeter using the Overture maps. So you can actually see here, here's the residential buildings in that area for each of these different fires. This station fire was obviously the largest, but a ton of areas, residential buildings in that area. So the fire side, matters much less. It gives you this whole kind of spit out and report. And this is what I love doing about this. You can do things like electrical lines and stuff like that. I'm asking for some different information around a demographic analysis here. And that's actually what's taking place right now, which I was running just at the start of this to get this going, which is actually create a basic, excuse me there, to build out a social vulnerability index based on demographic data. So that's what it's doing right now. It's actually taking a look at that and requesting that tool. And here's what it's doing is it's creating this index here for me from the SQL query, and I can actually ask it to write that and build that out. And those are all the pieces that are happening under the hood here as I'm actually talking and going with you. I can build all these different things and ask for that different information. So there's a ton of stuff that you can do here. And we'll let this go for a minute and I can ask some different questions here as well. And I can actually ask it once this is complete to actually turn this into a report for me. So here's great timing, Claude, for spinning that out. And you can see here, here's the SVI for these different fires, right? Based off of median household income, poverty percentage, over 65, and renter. And you can see here that the Quail fire and the Curve fire were the two largest for the SVIs. And you can actually showcase what that looks like. And it has this, wildfire equality sort of score. And you can see here that the largest one, which I believe was the station fire, still pretty high, but like it was a little bit lower here in terms of these different metrics. So you can kind of find some of these different pieces and it spits that out here. So what's cool now is I can do a few different things. So let's do both of these. I'm going to ask it to compress this logic into a Claude MD file for me to run in Claude Code. So it's going to take all this logic and I can do the same thing with the MCP over in Claude Code and build this into a notebook if I wanted to then run this as a job or run this repeatably and stuff like that. So we'll let this run here. The other thing that I can do is actually have it create a simple map dashboard, which is the other piece that I really like about this. So let me just drop that here and it's going to actually build this out. And then I can take this exploratory data logic that I built into this, move that into a productionalized code project and build that out. So we'll let that go here. And what it's going to do is it's going to look through all the different steps it needs and it already knows has context the data that it needs to do. It has the SQL commands it needs to run, and it's going to build all that into a project logic that I can actually take into my coding agent and build that out completely, which is the really cool part if I need to run this on a regular basis or if I need to bring my new data in. So that's one key step here. Now we'll let this run for a minute, and I just want to highlight a few other things as we're talking about the platform and the integrations and all those different pieces here. So there's a ton that you can do from this side. Now, this is data that's only in our open data portal, as well as if you sign up for an account to test this today, you get access to this pro data as well. But these are some of the data sets. It also has access to data that I've been putting into here and testing to load into our open data portal. So as you can see here, I have some different data from Landfire. These are some of this has different metrics around things like ignition data, stuff like that. This is all raster data, by the way. So if you see here, this is a tiled raster data set that it can, has things like 14 ignition fuels, or there's 13 and 40 that pulls in for Alaska and the, continental US, as well as, things like seasonal, components and stuff like that. So if you had a very specific interest in fire, we pull that data in. I'm pulling in some different data around like global movement observations and this is high resolution population grids from Meta. So I'm pulling that in as well. And again, that's a raster data set that you can pull in. So it doesn't matter if you're raster and vector, you can use that. I've been pulling in the complete ACS census, which you saw some of that data being pulled in. But this data is not public yet. We're working on moving this in, but we're also testing this on our side. So if you have your own data, you can ingest your own data that you want to bring forward and build that out and bring your own data alongside of this. It's very easy to ingest data from if you have shape files, if you have data on S3 and data sources and stuff like that, and you can bring all this in. And I actually pulled in this entire data set of the census. This is the 2024 ACS, American Community Survey data set. I did this using our MCP and actually orchestrating a process to actually build out this pipeline with these same AI tools. So I was able to design the pipeline, validate the data access, pull the data in programmatically from the census servers and build this out. And you can see here, this goes all the way down to the block group level. This one is for housing, and this contains all the different housing metrics from the census here. And we have a complete, data catalog that goes with this. We'll be releasing that. And we're adding skills that you can add into your coding agents to work with this specific data as well. So we're really focusing on creating a solid release with that. This is the historic storms data that you saw. So this is all the different data that you saw before. And then our storms warning, which literally just went live yesterday, that's already in the open data. So you have this storms warning data set. It's updating every hour. So as of this morning, it had 161 snapshots. Now it has 166. And every hour, we're going to be collecting that as long as we possibly can and go for it. So we'll call it forever from there. So all this data is eventually we're going to keep releasing and pushing this forward and getting more and more data into that. So I see a few questions here. We'll check in on Claude to see what it's doing here. And I'm going to let it do this while we're waiting along as well. So we'll see what it brings in there. But a few questions here is the main advantage of Wherobots platform and MCP versus straight Claude is I can handle much larger data sets and still remain performant. Well, there's a few advantages. Number one is that we're trying to push as much open data in as well for you just to access out of the box when you sign up. So, much like a Google Earth engine, we want to make this as advantageous as possible for you to have a wealth of data to start with. That's one. But the other part is the fact that our query engine underneath the hood, once it reaches those table formats, it's incredibly efficient to do these spatial lookups, right? Which is basically like, I'm looking in LA. Imagine a bounding box or a polygon. That's what our platform does like the best out of anything. So you can do that with GeoParquet. You can do that with a bunch of different things if you wrote those files yourself. But the combination of our internal indexing on top of the tables, which is built-in Iceberg, on top of the GeoParquet data, which we write, and we choose your partitions for you to be the most efficient for your data. We also have a spatial predicate pushdown, meaning that when we split the data up over the nodes of our compute, we can spread that across it very efficiently. And most distributed computing systems just split and partition the data based off of some element like a string or something like that. We can partition that spatially, so we can actually split that out. So our query time is 20 to 60 times faster than another system. So that's one piece there. The fact is that I can type something in and query the data set back very efficiently and get an answer from there, but I also have the spatial SQL logic built into that, so that that part of our MCP is actually a connection into our documentation. And then we're creating a bunch of sidecar skills that you can add in as well to do things like area weight interpolation or raster analytics and stuff like that. So increasingly that will just get easier, so you can add in more stuff and use those skills strategically alongside the MCP. So you're kind of building, it's a combination of the query component as well as that. And how does the Wherobots choose what data to make available in its open versus pro portal? Is it data originators? So it's not just data originators. It's some of it is data that we produce that like had like a cost or an extra API component associated with it. So there was some like licensing that we had to absorb for that. If it's open data, that's basically something that is open and easily accessible on the web. We try to make that in our open data and make that as accessible as possible. The pro data had some extra component associated with it. So I hope that kind of answered that question. So what I love about this so right now, the end goal of today was basically allow me to build this in, and I have this Claude, Claude Markdown file. I can basically copy this in here. And if I wanted to pull in, I think you can all still, if you can see the coding agent here, these are all my prompts here that I have. What I can do now is in my folder here, I can add a claude.md file, copy that in. It's going to tell it exactly what to do here and how to build this out. So it has the full context of my exploratory data analysis, which I didn't have to touch code for. If you don't want to, you don't have to touch it. You can do all these things and we'll show the dashboard result there. But what I can do now, and this is my favorite thing to do, is actually go in here, set it to plan mode, and say, create a plan for this project as outlined in the claude.md file. And I've built this entire concept. Now, a lot of times you want to build your own logic into this. This is a demo. So, I'm just trying to showcase you the capabilities. But you could write your own rules into this. You could use AI to scaffold it and build it, but you can actually do some of the different pieces here. And it's going to actually go and look in this, basically understanding what's in this repo, what it's asking me to do here, and all these different things. And then what it's going to do here is now push this out into again, What I love for pure exploratory use cases is Claude can do this whole thing here and build this out. And I do have to open this in Chrome because it connects into an actual map. So it won't allow me to call the map here from that. So let me just open this up. And then here's our actual map and quick dashboard. I've been loving building these demos and showcasing to what you can do here. So here's the 10 largest historical wildfires from this period, 3-mile buffer zones. And you can see here, it's created this really simple map for me to look at. These are the different fires based off of their buffer and reach, but it also has this SVI scoring here. So you can see here where this SVI score is. Quail has the highest SVA rank. Here's the metrics that populated into that. And then it actually gives you a really simple dashboard to look at that underneath. And again, this is maybe an hour's worth of work. I was able to get something really simple out. A simple dashboard allows me to build this out, and I can take this even further to start to understand. Okay, in these areas with high SVI rankings, where are the main evacuation routes? I can have it start to build the dashboard around that. Where are the heavy clusters of residential homes? And ask these different questions and take this even further as I keep pushing and pushing and pushing to get this to take it to different levels. But for an hour's worth of work, I have, and I could easily lift this whole thing up and move it over to Texas. I could go up to Montana, and depending on the data access that maybe you have or other areas, you could take this to different countries and do that. And that's the whole key here is that underneath all of this, there's a massive amount of data logic that's being built in. I'm querying, millions of properties. I'm looking at elevation profiles. I'm pulling in information about historic fires, properties, all this stuff that goes into it, and it can really start to scale this up and build this over time. And that's what I've been really enjoying about this and all these different pieces. So that's kind of the core demo that I had today. I'll check in to see if anyone had any specific questions. If you want to drop those in the comments or the Q&A, you can check those out. And more importantly, let's see here. If you want to check out Wherobots, you can actually go ahead and get started. You can sign up for this. You get $300 in credits, which will give you access to the MCP, the CLI, and all these different pieces during that 30 days. You can cancel anytime to do that. You can connect your own S3 storage. You can use ours. It gives you all these different pieces that you can pull into and actually do that. You can run your jobs and get your API access and do all of this. You can just start for free here and get started with those credits. And then after that, there's a sort of like a monthly sort of cost that it gets associated with that. And then again, it's completely ready to connect into Claude as of today. So you can do exactly what I showed you. If you go to the MCP, you click here. And if you want to bring it in right to Claude desktop, it tells you exactly how to do that here. So I can send these pieces over if that's something you want to check out. But that's kind of what we've been doing here. And I'm going to keep pushing a lot of these different use cases. You can follow us on LinkedIn. You'll see the data sets we're pushing forward, the things that we're building, all this different stuff that you can build, all in AI assisted pieces. And then you can actually build out complete full workflows here. And then I'm in the middle of turning this into a complete job that I can run. So you can see what I'm doing here. You can pull all these different pieces in and ask you what to do. And you can actually, how should the fire zone map be delivered? Save it as an HTML file and the default here, and it'll get that up and running, go from there. Any gaps you should be aware of using the MCP. There isn't really like major gaps. I mean, a lot of it is the core things is understanding some of the logics that you want to bring in. I just pull this in here. It's things like this where it's like, okay, where should I write the data to? What's the data logic that I need to bring in? There aren't really many gaps. I think some of the things that you can do to like fast forward this is like if you know the tables you want to use, give it that context beforehand. One thing that I've been doing is actually, if I go back to Claude here, I actually had like, and I should build this into a skill, and periodically update it, is I had it build like a full like schema and view of my data sets. So it's here. You can see it actually created a visual map of everything that's in our catalog. And this is out of date, like I haven't updated this, but it actually allows me to cache and say, here's the things that are available. So it can kind of skip some of those really early exploratory EDA steps. And that's sped up my work quite a bit, is actually saving it there. And then again, sidecarring that with specific skills that say, here's how to do this type of spatial join, like an area weight interpolation. I'm building a skill for that. We built a skill for data pipelines, bronze, silver, gold, medallion architecture pipelines, and how to build those. So we're building a repo and starting to release those as well. So if you want to check those out, you can actually do those too and bring those things in. So that's something you can bring to the table as well. So yeah, any other questions? Yeah, so if you want to check it out, you can go ahead and get signed up here. Again, you can get access to that 30 days free of credits, so you can actually start building this stuff on your own. If you have any questions for us, you can always reach out to me. You should have gotten an email from us or Tiffany. You can just respond to either of us with questions, or reach out to us directly via Wherobots. But we're happy to help you start and build the things that you're building on your own, and we're looking forward to that. So if you have any questions, don't hesitate to reach out to us. We'd love to hear from you and hear how we can help you build what you want. But for that, we'll leave it here for today. Hope that was helpful and informative. I try to keep these at about half an hour because I know hour-long webinars can be quite a bit for a lot of people. So we'll leave it there. But thank you all for joining me today. Again, hope to hear from you, and we will see you on the next one.